So, this talk probably won't be that powerful because I don't actually have any like real demos. Mostly because the hardware setup that I was using doesn't really tune itself well to kind of testing out RAID and to kind of testing out other things like ButterFS and just kind of a whole bunch of things. Next term I'd probably like to add to this stuff. So anyways, this is a whole bunch of stuff by me. Not a professional. I'm not representing, the co-op that I work for. I'm not the smartest person in the room. If you know more about RAID and I say something wrong, wait to roast me until the end. That'd be preferable. So the concept of RAID, like the concept of taking a whole bunch of disks, putting them in a giant array, and not only getting the throughput of all those disks, but also getting the increased storage capacity. That idea goes all the way back to super old IBM mainframes in the 60s. It wasn't actually called RAID until a paper was released. I think it was at Berkeley, 1980, during the years 1987, 1988. The actual acronym RAID, or Redundant Array of Inexpensive Disks, that actually came out to the public. The paper basically stated that cheap PC disks that were beginning to emerge in the early DOS systems, basically, if you had enough of them all strung up together, and if the operating system could actually recognize all those disks, use the throughput to the maximum, the paper stated that they could beat out any kind of super high-grade enterprise hardware. And kind of the actual RAID cards, as you could traditionally buy, like from probably Best Buy or some other sort of computer component store, that kind of traditional hardware setup goes all the way back to Windows 3.1, or at least that's what I could find. Yes?
When you say beat out, are you talking in terms of like write speed or read speed or storage capacity?
Kind of just the whole trifecta, really. I mean, there's going to be small like differences in every single system, or there might be like some other CPU load or whatever, and we can't write as fast as we normally do, or some other random thing.
So the idea is to get like basically the same performance but cheaper.
Right. Same performance, size, everything. Right. So if we're going to talk about RAID, and if we're going to compare it with ZFS, we kind of have to talk define what RAID is. So for the people who don't know, there's a whole bunch of different modes of RAID. Right. So they're typically defined by a number. I know some people that just call it what it is, like a mirror, a pool, or whatever. But a RAID 0 performs like a pool. It's really fast in the sense that you take both disks, hook them up to the controller, hook the controller up to some sort of interface on the motherboard, and then as you begin to write data to that device, now it's more of a logical device than anything, but as you write data to that device, the controller takes it, blasts it to the disks, and it can actually take it can asynchronously write data to basically both of the drives at the same time. So instead of writing block 1, waiting for that to write, then write block 2, waiting for that, then write block 3, kind of take the whole data as a pool, blast it to both of them. It's faster. It's actually the fastest method of RAID. There isn't any built-in safety to this mechanism, though, right? So if one drive dies, and you basically got one block over here, and this kind of evenly spread out distribution of blocks that it would take to build up a file. If you lose drive 2, you lose all the data. So it's not really built for safety, but a practical application for this could be maybe you're a video editor or something, and you just need to get a whole bunch of assets, to get a whole bunch of footage that you're constantly converting, and just blast it onto this giant pool because it's only temporary storage, that kind of a thing. Or you only need temporary storage. So, RAID 1. It acts exactly like a mirror. It's pretty fast in the sense that, you know, you just get the throughput of the regular disk. There is built-in redundancy because you literally have 2 copies of the data, but if you lose a drive, you know, replace it, put it back in, or put in a new one rather. The machine has to go physically copy over all that data. There's a single point of failure though, right? So, you know, that might be fine for you in your own little personal bubble world or whatever, but at the enterprise level, what I've seen and heard of is basically that you need more protections than a simple mirror and one point of failure. Because if one drive fails and they're identical drives, well, chances are, you know, drive 1 is about to wear out and give out 2. And a lot of the times what happens in other setups, like in RAID 5, we'll get to that in a second, but like in RAID 5, what happens a lot of the times is that you go to actually rebuild all this parity stuff, you know, with your new drive in, but as you're rebuilding it, another drive dies, and oh well, you're SOL. So RAID 1's okay. It's okay. There were other forms of RAID, namely RAID 2, 3, and 4. They're basically all dead. The concept was that you could actually take all these drives, set them up in like a RAID 2, 3, or 4, whatever kind of scenario, but you have a whole drive that's dedicated specifically to this kind of parity. So basically, you take a block and you kind of split it into multiple chunks, and then you take the whole thing and you compute the mathematical parity on it, and then you store the parity on the other drive, in this case. And so the thought is that if you lose a drive, you can pull out that drive, and then when you put in the new thing, you take the pieces that you actually have, and you like reverse math, or you do math in whatever order you need to, and then you get back all the data that was on the other drive. This kind of sucked in terms of read and write speeds. Well, random read and write speeds. So it just kind of died out. You can't really find a whole bunch of information about it. So yeah, survival of the fittest, I guess. I don't know. It died. So RAID 5 is not only the fastest of all of the parity using setups, but it's also, you know, the parity setup that requires the least amount of disks. So I think I get to this later in the presentation, but whenever you're setting up anything to use this kind of mathematical parity kind of thing to ensure that your data will still be there, basically, you know, to figure out how many drives you'll need, you take a power of 2, and then you add however many drives that you'll need for parity. So RAID 5 needs at least 2 disks. RAID 5 needs 1 parity disk, so you can take any power of 2, and then you can slap on 1 extra parity disk, and there you go. What else did I say? Oh, yeah, so in terms of, you know, actual drive failure and you going to rebuild the entire array, as hard drive capacities increase, that process is going to take, you know, exponentially longer, kind of. So just like in the mirror scenario, what happens, you know, drive dies, pull it out, put a new one in. And as you go to rebuild that by doing math and whatever, the larger the capacity of the drive basically decreases your chances of success. Because, you know, if you're going to buy all the drives at the same time and shove them into a machine, chances are that, you know, other 2 drives are basically going to die. So you really shouldn't be using any disks that are greater than, you know, 2 terabytes in size. I've seen a lot of people that kind of don't like to use anything larger than a terabyte or larger than like 750 gigs, just because of the actual chances of success.
So by chances of success, you mean you want to have a small drive so that you're only copying or recovering a small amount of data when it fails, because the other drives might be failing during that time?
Right. Yeah, I don't know. There just isn't really any way around it. The whole situation is just kind of a little messy in terms of drive failure. So, I mean, RAID 6, you have two parity drives. I say parity drives with quote because the parity is actually stored across all of the platters, not just one. You can have two drives fail before you've lost all of the data. So this increases security in the thought that if you have a drive die, pull it out, put a new one in, and you can begin to rebuild it. And if you have a drive die in that process, you can still pull it out, put a new one in, and you still have your data. But you're really cutting it close, in my opinion, just because everything's about to die. So, problems, hardware misreads aren't taken care of. Inside of the RAID 0 system and inside of the RAID 1 mirror system, right? So inside of the giant pool, you kind of expect things to go wrong just because it acts and behaves just like a regular single disk, except, there's two. And so you get the space of two, but you get the exact same behaviors as OneDrive. In terms of the mirror situation, it's almost a crapshoot with what the actual RAID card, if it doesn't have any kind of checking capabilities, which a lot of RAID cards don't. So what'll happen is that you've got your mirror, and if one of the drives doesn't necessarily begin to fail mechanically, but if you've got something like bit rot, where the actual physical bits by cosmic means or by some other miraculous kind of thing, if the actual bits just switch, you either get lucky and you look at the disk that has the good data, or you get unlucky and you look at the disk that has bad data, and you go, oh, my CS102 homework, it's all gone, or whatever. Larger than 2 terabyte disks still basically suck, just because of rebuild time. So, it's supposed to be a question mark. But anyways, so when I set out to just kind of build a whole pool of space, I was kind of looking at RAID, and I said, why would I want to buy a whole other controller when I can just use some sort of software RAID? And now, disclaimer, software RAID doesn't have as many faults that the actual hardware RAID does, simply because software RAID can implement some more checksumming kind of things. But I just decided to use a file system that just took care of it. So I could say, here's my disks, take the stuff. So RAID began as kind of an experiment in IBM labs and made its way into production, and ZFS basically came about because somebody entered a command wrong at Sun Microsystems, and 2 engineers were so fed up that they had to stop their entire workflow to wait for the entire RAID array to rebuild from parity and a backup, that they basically went off, took 2 years, they made ZFS. Now it's in production in a whole bunch of places. So ZFS has checksums, block by block. So when you actually store something on ZFS, the process is basically, you're going to write your giant movie or whatever to the disk. It takes all that space, and it begins to put it into memory, right? And then inside of memory is where all of these checksumming, what else do I say? These checksumming, compression, and these other kind of nice things happen. Virus scanning, if you choose to use it. Virus scanning also happens inside of memory. Well, when you're writing. It's a little different if you're going to actually, go through the entire pool. But checksums are block by block. So when you actually go to check the integrity of the entire array, ZFS will tell you down to the block what block is actually corrupted. So ZFS also provides RAID without the actual RAID card. Kind of. If you're thinking about using ZFS with traditional PC hardware, there's basically some sort of limit on the actual amount of SATA interfaces that you have on the board. And a way that a lot of people get around this is they actually buy a RAID card and they set up to just use like SATA pass-through. So every single device that you plug into the ZFS, every device that you plug into the RAID card just reports itself to the operating system as an individual disk, and it's not actually handled by the RAID card or anything. That gets you around the whole, oh, what if this RAID card handles parity slightly different than this RAID card does? And it can kind of just get you around a whole lot of things where hardware kind of falls short. And it can actually just do snapshots, just on the fly. So by snapshots, I don't mean let's take the entire pool, copy it, put it somewhere else, and then let's begin to continue normal operations. What a snapshot does is it actually just records all the differences in between wherever you created the snapshot and what you've done up to the present. So these are actually just a whole bunch of properties of an actual ZFS data set. A data set reports itself to the operating system as a mountable object. It's all kind of abstract, but all of these are actually individual properties inside of a giant list of other properties, right? So you've got vscan here for provider scanning. You've got checksumming up there, compression. You can actually set the decompression ratio. You can set the actual algorithms that you're using to compress things. Sky's the limit with this. You can even make your own properties. So like let's say you want to make sure that the intern gets donuts or something, right? You could just set a ZFS property on his data set, donuts equals true, and then whenever donuts is true, he's got to go eat donuts. It's a dumb example, but you can just make any property that you want. So let's do the cool things. My setup was kind of crappy. I had basically a spare terabyte disk and a 250 gig terabyte disk laying around, and I said I want to do this right now, right? So I basically took those two, right, dev/SDD and dev/SDC, and I decided to make just a pool, right? So I didn't have any redundancy. If you're going to use redundancy, you actually need to have drives that are exactly the same. I couldn't really test that out. So instead of putting it on physical hardware, I didn't really have space to do that. So I just decided that I'd run a virtual machine, pass through all the stuff, give it a whole bunch of memory, and just let it go. Now, I don't know if anybody's ever tried to actually figure out what physical devices you have on Windows, but it is the most dumb thing I've ever seen. So on Linux or any other kind of Unix, there's a whole bunch of methods, right? They're basically all of the devices are represented as files. You just go look for the file that's represented by a disk, and you're done. With Windows, if you actually go to run this command here, right? WMIC disk drive list whatever, and you don't actually blast it out to a file, you get a whole bunch of crap. And I just sat there and I'm like, well, what the heck? This is stupid. Redirect it to a file, and you're good. If you weren't paying attention, the Windows terminal console, whatever, it sucks. So I had a terabyte hard drive. I had a 250 gig hard drive. All I could do was set them up in a pool. So since I was using Virtualbox, because This is the only virtualization thing I've ever used. You have to use VBox manage, and you have to create a raw disk, and then you create a raw virtual mountable disk, whatever. And then you just enumerate the actual physical drive with what you got from the WMIC thing earlier. Also, if you attempt to use any kind of physical hardware directly without Windows interfacing with it, inside of Virtualbox at least, I assume it could be true for everything, but at least inside of Virtualbox, you have to run it as an administrator. And if you don't, the actual disks will show up inside of the virtualized OS, but every single time you go to use them, the virtual machine will die because I don't know. Just run it as admin, just to get the actual physical disk I/O, and you'll be good. If you're worried about security stuff, deal with that on your own time. So I installed Debian mostly for stability. It's really what the operating system totes around, is that it's the most stable. Well, Debian stable is the most stable. I probably should have used FreeBSD just because they've got a lot of nicer tools to not only do ZFS stuff natively, but to also kind of do some like routing stuff, which will actually come into presentation later. So after I installed Debian, I installed ZFS. You can just Google ZFS on Linux and you'll find the thing. And then I set up a Samba share, just for people to I can't think. Just for people to be able to go to their File Explorer, type in an address, and it shows up as a network thing. Because really, that was the goal, is just sharing a whole bunch of stuff over the network. So once I installed ZFS, I basically created the ZFS pool. Well, I made the ZFS data set called file share. Those are the two devices that I used. And then, after running that, it mounts itself to root. And if you wanted to enable compression, if you wanted to enable anything else on that giant list of properties, you could simply say, where is it? Okay, so, I made a specifically compressed folder in this example, but, ZFS set compression equals to whatever algorithm or program. I think you have to use a program, but, so set the compression equal to whatever programming you want to use. Tell it what data set you'd like to use, and then compression's on for the data set.
Just a heads up, it's 105, so you got
Really? Holy crap, why do I take forever for this? Anyways, you can turn off compression with compression equals off, and then the data set. You can make a RAID 5, 6, 7 setup with a with basically the same command, except you have to define that it's actually a RAID Z whatever. So 5 correlates to a RAID Z1, 6 correlates to a RAID Z2, and then a RAID Z3 correlates to a regular RAID 7. RAID Z is slightly different than actual RAID, simply because RAID Z handles checksumming, and then it does a parity of those checksums and a whole bunch of stuff. Same rules apply in terms of RAID Z. Can't really use a whole bunch of huge disks, just because they'll die, and then you'll lose a whole bunch of stuff. This is how you replace a drive. You gotta make sure that the disk is offline, turn it off, hot swap it, whatever, and then you replace that. And then you can actually, if I spelled the data set right, you can actually see that, either the status would be rebuilding that disk, or it would just be available in terms of the whole array of disks, really. Did I skip anything? No. To clean up the pool, just to make sure that your data is actually all there. If you aren't using any kind of a RAID method, you'd probably want to scrub the pool more often than you did with a regular RAID thing. So, when you scrub the pool, you're actually taking all those checksumming the files, comparing them. If they're the same, you're all good. If they're not the same, and you have a backup built into ZFS somewhere, or you've got like a snapshot or whatever, it'll automatically take that file from the snapshot, and then whenever you actually run that status command, it'll actually tell you, hey, we replaced this file with whatever. You should check and see if that's an okay situation. If it's got parity, it'll rebuild it from parity right there. Right when it finds it during the scrub. You should stick it in a cron. You should stick it in your cron tab just so it runs automatically, so you don't have any bad times. Then I set up a Samba share. So, I set it up. Samba's kind of disgusting because Windows permissions and Unix permissions are 100% different. So anytime I go and I look at it, it'd be like, oh, everything's executable. It's disgusting. Anyways, so I forwarded port 139, and then I could get all my buddies in the unit to just basically go to there, or to go to the actual address that Kettering assigns, and then they could just look at my CS102 notes or whatever. 5 people could stream movies concurrently over the network. The only bottleneck was the actual dinky $40 router that I had. And the only downtime that I had was whenever Windows 7 decided to be dumb. So yeah, don't use Windows as a host OS. It doesn't like anything. In the future, I'm going to actually have one box to rule them all, kind of a thing. So that box is going to be my router, so I get full gigabit out to like whatever network I connect to, and then I'm going to set up ZFS with just a whole bunch of disks. I don't know. It'll be backups, movie streaming, and free in terms of my family wouldn't have to like pay for a whole bunch of cloud storage or whatever. Once again, Samba's dumb. So I think I'd set up just like a web server that you could connect to, and then it'd have like a whole tree structure. And
why not just have a Plex server sit on it?
Because I haven't looked into that at all. I don't know. I just haven't looked into any other solutions. Okay. And laugh in the face of danger. Kind of. No. The Linux philosophy, according to its kernel's creator, is do it yourself. So I did it myself. It sucked, kind of, but I can make it better by doing it myself. Ta-da.